show that in a right angle triangle, the hypotenuse is the longest side. Now let us take this triangle PQR to be a right angle triangle. Here angle Q is 90 degree. So as we all know, in right angle triangle PQR, measure of angle P plus measure of angle Q plus measure of angle R is equal to 180 degree, right? But as we know, it is a right angle triangle, so Q is 90 degree. So we'll be writing angle P plus 90 plus angle R is equal to 180 degree. So we will be getting angle P plus angle R is equal to 180 degree minus 90 degree, which is equal to 90 degree. That means the sum of remaining two angles is 90. So this shows that angle P will be lesser than 90 degree, as well as angle R also will be lesser than 90 degree. That means these both angles are acute angles. So thus I can also write, in place of 90 degree I can replace it by angle Q. So angle P is lesser than the measure of angle Q, and similarly angle R will be lesser than the measurement of angle Q. So according to the theorem number 7.7, we have already learned, if two angles are unequal, then the opposite sides also will be unequal in the same way. So here you can see angle P is the smaller angle. So opposite sides of angle P will be QR. So QR will be smaller than opposite side to angle Q, which is PR, right? Similarly here, which is the opposite side to angle R, it is PQ. PQ will be smaller than PR because PR is the opposite side of angle Q. So here you can see in both the situation you are getting this PR is greater than PQ as well as QR, and so we can say PR is the longest side. Okay, and now you can see in the figure PR is actually the hypotenuse. So we can say in a right angle triangle, the side which is opposite to right angle, that means the hypotenuse is the longest side, and hence the result is proved. Let us see to our new question. Sides AB and AC of triangle ABC are extended to points P and Q respectively. So you can see A, B and P. Okay, that means P is a point after B. Similarly you have A dash, C dash, Q. That means they are collinear in the same order. It is given that measure of angle PBC is lesser than angle QCB. That means, just imagine, I am just showing you for an example. Suppose if you take QCB to be 110 degree. So this angle PBC will be 100 degree because 100 is lesser than 110. So this just for the sake of understanding I have taken. Now you can see this angle ABC is forming linear pair with PBC. So if this is 100 degree, so its linear pair will be 80 degree, as linear pair of angles are always supplementary. Similarly, angle ACB will form linear pair with angle BCQ. So here if you have 110 degree, so this will be obviously 70 degree. Now what can you say about the linear pair of angle? If you have angle PBC is lesser than QCB, then their linear pair angle ABC will be greater than, this sign will change, it will be greater than angle ACB. And if this angle is greater and this is smaller, so the side opposite to the greater angle, that is AC, will be the larger side, and the side opposite to angle C, that is AB, will be the smaller side. So let us write it stepwise. So you can see I have written as angle PBC is lesser than angle QCB. So ABC will be greater than angle ACB because of linear pair of angles. Thus in triangle ABC, as you have two unequal angles, so by theorem number 7.7, the side opposite to angle ABC will be greater and the side opposite to angle ACB will be smaller. Now let us see, in the given figure, angle B is smaller than angle A. This is given here, right? So no need to see the second triangle right now. We'll concentrate on the first one. In triangle AOB, as angle B is smaller than angle A, so the opposite side to angle B is OA. So OA will be smaller to the opposite side of angle A, that will be OB. Okay, so this is result number 1 by theorem number 7.7. In the same way you can talk about the second triangle DOC. So in triangle DOC, as angle C is smaller than angle D. Okay, now angle C is smaller, so the side opposite to angle C will be OD. So OD will be smaller than the side opposite to angle D, that is OC. Okay, so this is result number 2. Okay, so again this result is proved by theorem number 7.7. As we have got two results, here we have got OA is lesser than OB and here OD is lesser than OC. Adding result number 1 and 2, so on the left hand side I will be getting OA plus OD is lesser than OB plus OC. So what is OA plus OD? OA plus OD will make full line segment AD. So AD will be smaller than what is OB plus OC, that is equal to BC, and this result only we needed to prove, and hence our result is proved. So let us see our next question. As shown in the figure, we have PR bigger than PQ. So PR is the bigger side and PQ is the smaller side. Also ray PS bisects angle P. So these two angles are equal in measure. So we need to prove that this angle PSR is bigger as compared to angle PSQ. So I have written what we need to prove. Now as PS bisects angle P, so we can write angle QPS is equal to angle RPS. That is result number 1. Also we have PR is greater than PQ, and so by theorem number 7.6 we can have this angle Q will be greater and angle R will be smaller. So I can write angle PQR is greater than angle PRQ. This angle PQR can be written as PQS. So as you have Q dash S dash R, that means they are collinear points, the same result can be rewritten as angle PQS is greater than angle PRS. This result we will be using in proving the sum. Okay, now you can see the two results what we have proved. Now if you imagine this triangle in this way, okay, this is triangle PQS having angle PSR to be an exterior angle. So we have already learned in 9th standard the measure of exterior angle PSR is equal to sum of its interior opposite angle. So we will be getting it is equal to QPS plus angle PQS. Similarly, for the second triangle PSR, this PSQ will be considered to be the exterior angle, and so I will be writing angle PSQ is equal to angle RPS plus angle RPRS, right? So this way we will be getting two important results. Now these two important results are really important. You can see what I had written in result number 1. It was QPS and RPS are equal. So that means these two angles are perfectly equal, right? Also PQS and PRS, we have derived the result. Here PQS is greater and PRQ is smaller. Okay. Now this PSR and PSQ are forming linear pair. Okay, so you can see PSR and PSQ are forming linear pair. So let us write up to that. Now this I have named as result number 3. What I will do is I will write this angle again by result number 2. Angle PQS is greater than PRS. Now these two angles are equal in measure, so I will add QPS in PQS and angle PRS will be added with angle RPS. Okay. On the left hand side I will get angle PQS plus QPS. Now what is actually PQS plus QPS is PSR by result number 3. Okay, and on the right hand side I will be getting PRS plus angle RPS, that is PRS plus angle RPS is PSQ. So we will get our desired result. So let us see how to write. Now you can see I have written by result number 2 angle PQS is greater than PRS. These QPS and RPS are equal angles, so this sign of greater than will not change because I am adding equal angles. Now by result number 3, PQS plus QPS will become angle PSR, okay, and it is greater than angle PRS plus angle RPS, which was angle PSQ, and thus the result is proved.